Hey, hope you're doing well. We're going to move on to compound inequalities, and our objective is to consider inequalities and whether they will go on forever always to the left or forever always to the right. I think you should remember from 1.5 where we had I was showing you how to write interval notation. You notice that sometimes that the inequalities went between two endpoints. All right, that's a compound inequality. And sometimes we had inequalities going off in different directions. So like this. Okay, that's a compound inequality. So more than one inequality is occurring at the same time. So how do I solve an inequality that has the word and in it? I want one inequality to be true and I want another inequality to be true at the same time. And an objective is how do I solve an inequality with OR? So with an OR, I can have either one of two inequalities being true or both of them being true. So let's figure out how we can do this. These are some terms that have been added to Quizlet this week. Make sure you go through and look at those. I'm not going to read them and let you read those on your own. You can ask me questions. All right, a compound and. With a compound and, the variable is between two endpoints. So if we look at this and inequality statement, 3x minus 7 is greater than 8, and 3x minus 7 is less than or equal to 23, whenever we have the word and, we want to translate it into a simpler expression, okay? What we do is we put the variable expression in the middle. We put this is the variable expression. This is the smallest number goes on the left. Remember, that seems to be a theme. Smallest on left, and then the biggest on the right. And look at the direction of our inequality symbols. They're always pointing to the left. They're always a less than symbol, okay? So the first thing that we want to do is we want to isolate that variable. So we're going to have to add 7. Think of this as 3 separate pieces, the left piece, the middle piece, and the right piece. Whatever you do to the middle piece, you have to do both to the right and to the, both to the left and to the right. So I'm going to add 7 to both all 3 sides. So I get 15 is less than 3x, which is less than or equal to 30. I added 7 everywhere. Add 7 to all sections. Now I'm going to divide by this coefficient of 3 that's on the x. I'm going to divide everything by 3. And I get 5 is less than x, which is less than or equal to 10. And if I write it in set notation that we've already learned, all x's such that. Okay? If I write it in interval notation, the 5 is associated with this exclusive symbol, so it's parenthesis 5, comma, 10, bracket. And we graph it on the number line. So I'm going to go up by 2's. So here's 0, 2, 4, 6, 8, 10. So I have 5 is here. And that should be open. Sorry about that. And 10 is here, and that should be closed. And then the line between them. That's what a compound and looks like. Okay, let's try another one. Notice that what I did was I put my smallest number here, my largest number here and my expression in the middle. Now I'm going to isolate my variable. I'm going to subtract 8 from everywhere. So every single section, okay? And then I get negative 20 is less than 4x is less than or equal to 32 minus 8 is 24. And now I'm going to divide everything through by that coefficient on x. And I get negative 5 is less than x is less than or equal to 6. To write in set notation, all I do is add the good stuff, my braces, and my vertical line. To write in interval notation, I have my smallest number is negative 5. That is excluded. And then my biggest number is 6. That is included. So to graph on a number line, I need to go from 5 to 6. So let's go 0, negative 2, negative 4. Here's negative 5, open. 2, 4, 6 is closed. And then we go like that, a line in between. That's the compound and. Okay. Now a compound or, we have an or in between, okay? And what we do is we keep these two equations completely separate and solve each inequality separately. I'm going to add the word separately, write that down. Separately. So I'm going to subtract 6, and I get k is less than negative 10. And then on this one, I'm going to divide through by 3, and I get k is greater than 4. Okay, so let's do 0, 2, and 4. Let's see about that. And then negative 2, negative 4, negative 6. Okay, I barely can fit this. Negative 10. Can you guys read that? That's an 8. All right, k is less than 10, open, because it's exclusive, and then it has to go off to the left. K is greater than 4, open, and off to the right. Now in set notation, I'm going to have to squeeze this down just a smidge, okay? We're just going to put the fun stuff on it, all k's, such that k is less than negative 10, or k is greater than 4. That should be a brace there, not a... In interval notation, remember this section in here, this is going to translate into a u, okay? So we have a negative infinity, that's our smallest number, to negative 10. All right, both of those are parentheses because it's all exclusive. Union 4 to positive infinity. Okay, any of these that you don't quite get the first time, go back and watch it again. All right, with an or, we keep everything separate. We don't write it as a nested one like we did with and, okay? So I'm going to solve each one separately. First one I'm going to divide through by 5, so x is greater than or equal to 3, or, and here I'm going to divide by a negative. X is less than or equal to negative 7. I have to flip that, don't forget. All right, so I'm going to graph it on a number line. I'm going to, here's 0, 2, 2, 4, 6. X is greater than or equal to 3. That's going to be right between 2 and 4, closed. And then off to the right. Less than or equal to -7, -2, -4, -6, -8. So here we are, and this 2 is closed, filled in, and then off to the right, sorry, off to the left. Set notation, all x's such that x is less than or equal to -7 or x is greater than or equal to 3 in a bracket. In interval notation, we have -infinity to -7. Negative infinity, infinity always has a parenthesis, -7 always has a bracket. Sorry, that's not fitting in there. Union, bracket 3 to positive infinity, parenthesis. Right? One more. I'm going to solve each separately. I'm going to add 6. So x is greater than -5. Or I'm going to add 4 here. Notice how both of these are greater than symbols. So let's figure out what this is going to mean. Okay, so here's 0, -1, -2, -3, -4, -5, -6, -7. Remember, with an OR, the solutions can be in either one of them or both of them. So I have -5 open and then going off to the right, and then I have -7 closed, also going off to the right. And they overlap, don't they? That's interesting. So that means as if it's in this bottom line or in this top line or in both of them, I get to include it. So in set notation, this is just all x's such that x is greater than or equal to, you have to pick the longest line, 7. -7. Because I can have -7, that makes this true. -6, -5, -4, -3, -2, -1. And then it also covers this -5 going to the right. Okay? So in interval notation, it's going to be bracket -7, comma, positive infinity, parenthesis. That's kind of interesting, isn't it? All right. These are the daily assignment that we're going to do. If you want to get started, remember Quizlet is due Friday. Quizlet Friday. All right, thanks.